Right, we're going to be building on our proofs now. We're going to prove some things about quadrilaterals and parallelograms. Typically, these are parallelogram proofs. So what you see here are some things that are true about parallelograms. Opposite sides parallel, congruent, angles are congruent, diagonals bisect each other, consecutive angles are supplementary. So the thing is, if we're given a parallelogram, then all of these are true, and we can use them as statements and reasons in our proof. If we're trying to prove a parallelogram, though, if we're given a quadrilateral and we're asked to either prove the quadrilateral is a parallelogram or prove other things where knowing a parallelogram exists is helpful, then we just have to show that one is true. So we don't have to prove that all 5 of these things are true in a parallelogram. We only need to really prove one of them. So we'll come back and we'll do definitely some proofs on proving things are parallelograms. Let's start with one that is a parallelogram. So we're told figure ABCD is a parallelogram. AP is congruent to QC. Let me mark AP congruent to QC. And I want to show that AC and PQ bisect each other. So I think my plan is going to be something like this. I'm going to try to show that green triangle congruent to this red triangle. That's going to be my plan. If I can show that those 2 triangles are congruent, then I know by CP/CTC that AR and CR are congruent, and also PR and QR are congruent, and therefore AC and PQ bisect each other. So let's use the fact that we're given a parallelogram. So again, we're going to start by writing down our givens. So I'm given parallelogram ABCD. And now let me use the fact that it's a parallelogram to get some other things that are true. So for example, my given is that AP is congruent to QC. So there's one pair of sides. I better prove some angles are congruent. So one thing that I know is that in a parallelogram, the opposite sides are parallel. So I'm going to say that side AB is parallel to CD. And that is true because in a parallelogram, opposite sides are parallel. And since AB is parallel to CD, it creates a pair of alternate interior angles. So from here, I'll say that angle PAR is congruent to angle QCR. And again, those angles are congruent because parallel lines that are cut by a transversal create congruent alternate interior angles. So we'll use that AIA conjecture. This was also given. Now, if you want to, you can say by the same reasons before, by that AIA, that these 2 angles are congruent. We can do that if you'd like. What I think I'm going to do instead, though, is I'm going to prove the vertical angles are congruent. I'm going to prove that these 2 angles are congruent. So angle ARP is congruent to angle CRQ, and that's by our vertical angle conjecture, or by writing that vertical angles are congruent, which is what the conjecture says. So now I have enough to prove the triangle is congruent. So I'm going to say that triangle APR is congruent to triangle CQR, and those 2 triangles are congruent by angle, angle, side, AAS. So again, my plan was to get the triangles congruent, and then by CP/CTC to say that AR is congruent to CR, and in the same step, I'm going to say that PR is congruent to QR, because it's true by the same reason, CP/CTC. And then the final thing that we're going to say is that by the definition of bisector, that AC and PQ bisect each other. So that's going to go in my box. Underneath my box is the definition of bisector. Because if I asked you, hey, what does a bisector do? You'd say it cuts 2 things in half and makes equal pieces. Well, there's our equal pieces right before it, the CPCTC. So here's our proof. What's the new thing in the proof? The new thing is that you used a parallelogram to get opposite sides parallel. That's the only new thing that we really did. The rest of it is older stuff. And that's really what these proofs are. They're triangle proofs with a parallelogram hidden in there. So let's take a look at our next one. We're given another parallelogram ABCD, and now I'm given some right angles. I'm given that BY is perpendicular to AC, so I know I got some right angles there, and that DX is perpendicular to AC. So I got some right angles there as well. And I want to prove that DX is congruent to BY. So again, let me come up with a plan. I'm thinking that my plan is I'm going to prove this green triangle and this green triangle congruent because they contain sides DX and BY. So then I know I have a pair of 90-degree angles in them. Since I'm given a parallelogram, I've got opposite sides congruent. I also know the opposite sides are parallel, so I can get some alternate interior angles there as well. So I think that's my plan. I think that's the direction I want to go. So let me start off. Given parallelogram ABCD. So from there, I'll first start by saying that side AD is parallel to side BC. And that's because the opposite sides are parallel. I also am going to say, and let's maybe come down this way for that, I'm going to say that AD is congruent to BC. I'm going to actually just tweak this a little tiny bit, and I'll show you why. I'll show you why. Because as a result of these two sides being parallel, I'm going to say that angle DAX is congruent to angle BCY. I'm going to say that's true by AIA. I'm just thinking like organization-wise. Because AB is or ABCD is a parallelogram, now I'll say that AD is congruent to BC. And that's because the opposite sides are congruent in a parallelogram. So now I got an angle, I got a side. Now I got to handle my right angles. So remember that after we list our givens, that BY is perpendicular to AC, and also that DX is perpendicular to AC, AC. These two things are given. Remember that perpendicular lines make 90-degree angles. So because BY is perpendicular to AC, I'm going to say that angle BYC, its measure, is 90. And that's true by the definition of perpendicular. We'll do the same thing over here and say that angle AXD, actually we should go the other way. If we said BYC, we should probably say angle DXA is 90. Now I've got two angles that measure 90, so therefore angle BYC is congruent to angle DXA because these two right angles and all right angles are congruent. So again, that's old stuff. We've done triangle proofs where we've proved lines perpendicular, or we've done perpendiculars to right angles. We've done all that. So now I can start pulling some things together. Now I can say that my triangles DAX is congruent to triangle BCY. And I can say that those triangles are congruent by angle, angle, side. And then if the triangles are congruent, by CPCTC, side DX is congruent to side BY. So what I'm hoping you see so far is that when we do these quadrilateral proofs, it really is a triangle proof where we have a parallelogram in it as well. All the parallelogram does is give us some extra reasons that we can choose from to prove triangles congruent. So let's keep moving. Let's change gears a little bit. And now we're given a quadrilateral. But take a look at this quadrilateral. Look at this ABCD. What kind of shape does it look like? It looks like it's a parallelogram. Yeah. So that means we have to show that there's like one of these properties. Let's go way back to the beginning for a second. We got to show that one of these things are true. Let's go and do that. So I know that AB is parallel to CD. So I'm thinking now parallel lines, alternate interior angles. I know AB is congruent to CD. So that's not too bad. So I'm going to get like a side angle. You see the shared side in there? Gotcha. So let's see. If AB is parallel to CD, if that's given, then what I'm going to say is that angle BAC is congruent to angle DCA by AIA. Hey, we've seen that 3 times today, that these two angles are congruent because the lines are parallel. Great. I also know that AB is congruent to CD. That was given. I also know that side AC is congruent to itself. It is a shared side. So I got those 3 things true. So my triangles are going to be congruent. And now here's what I'm thinking. If my triangles are congruent, then I know that side BC and side AD are congruent. And then I got opposite sides parallel. So I think that's my plan. So I'm going to say that triangle ABC is congruent to triangle CDA. And that's going to be true by side, angle, side. And again, let's say now that side AD is congruent to side BC. And that's true by CPCTC. Now, I got to draw another like crazy arrow here for a second. Because as these 2 sides are congruent and those 2 sides are congruent, ABCD has to be a parallelogram because its opposite sides are congruent. And I think opposite sides being congruent is the most direct way to prove ABCD is a parallelogram in this situation. The reason being is because I already knew that I had one pair of sides congruent. So to say the other pair by CPCTC makes it pretty easy. I mean, maybe do you want to say that these green angles are congruent? And therefore, those are alternate interior angles that create parallel lines and say opposite sides parallel? We could do that. You want to do angle addition and add up angles to get opposite angles congruent? We could do that. That's kind of crazy. But I think in this case, opposite sides congruent is the way to go. But there's a bigger thing here. Look at what we were given. We were given a quadrilateral that had one pair of sides that were both parallel and congruent. And we proved it's a parallelogram. That's big stuff. So I'm going to go back here to the beginning, and I'm going to also add in that in a parallelogram, it has one pair of sides that are both parallel and congruent. So let's add that to our properties of parallelograms. And this is one that I like to use when I'm proving things are parallelograms. I like to say, hey, because it has one pair of sides parallel and congruent, it's got to be a parallelogram. So let's do one more together. So I'm given a quadrilateral. I'm given some information about some sides. And I know something big here. First of all, I know it's a quadrilateral, but what kind of shape is that green shape? Here's a big hint for you. You want to be successful on tests? Here's what you got to do. If you're given a quadrilateral that looks a lot like a parallelogram, it is a parallelogram. The first thing you should do then is prove it's a parallelogram. So how do I do that? Well, look what you were given. You were given AD congruent to CB, and you're given AD parallel to CB. So the first thing I see is I got one pair of sides that are both parallel and congruent. So right off the bat, I'm going to say this thing's a parallelogram. So I'm going to start by saying that AD is parallel to CB. That's given. And I'm going to say that AD is congruent to CB. That's given. And these two things unlock parallelogram ABCD for me. Because I got one pair of sides, parallel and congruent. So again, if you're given a quadrilateral that sure as heck looks like a parallelogram, it is a parallelogram. Prove that it is. So now I got a lot of good things here. Now let me come up with a plan. If I want to prove that I is the midpoint of JK, I want to prove that that green segment and that red segment are congruent, which means that I want to prove that this green triangle is congruent to this red triangle. I got to prove those two triangles congruent. And I know I got myself a parallelogram. So I'm thinking of some things. I know that I got AJ congruent to CK. That was given. How about a pair of vertical angles? I got that. Maybe we can use the fact that it's a parallelogram and we have parallel sides to get a pair of alternate interior angles. Yeah, parallelogram proofs just scream to use alternate interior angles. They really do. So let's see. Since the thing's a parallelogram, what I'm going to do is I'm going to say that side AB is parallel to side CD. Because the opposite sides of a parallelogram are parallel. So now that side AB is parallel to side CD, now I know that I can say maybe angle JAI, this angle here, is congruent to angle KCI. And that's going to be true by AIA. Those kind of go together. Prove pair of sides parallel and then use AIA to get angles congruent. So we're just about done with this proof. We were also given that AJ is congruent to CK. We were also given, or we weren't given it, but I've got a pair of vertical angles, AIJ and angle CIK. Vertical angles are congruent. So then my triangles are congruent. Triangle AIJ congruent to triangle CIK, and it's congruent by angle, angle, side. So finishing this thing up, let's prove that I is the midpoint of JK by saying that JI is congruent to KI by CPCTC, and that arrow goes there. And that means that I is the midpoint of JK. And our reason is the definition of a midpoint. So that's our idea about quadrilateral proofs. I hope you realize that's just really a triangle proof that has a parallelogram thrown into it.